final leg of my journey takes me just over 300 kilometers south to the city-state of Singapore. Tucked at the bottom of the Malaysian peninsula, Singapore enjoys a somewhat sheltered geographical position. It has no history of seismic, volcanic, or oceanic disturbances, but is surrounded by some of the most active fault lines on the planet. Across town at the Earth Observatory of Singapore, a lecture is underway discussing the possible causes of the Sabah earthquake.
Here's Mount Kinabalu. These valleys right here, nobody's ever actually studied them with respect to earthquakes because they're so...
Professor Kerry Sear spent 30 years studying and researching earthquakes in the US. In 2008, he moved to Singapore to set up the Earth Observatory here at Nanyang Technological University. I've come with questions about why we are seeing an increase in seismic activity in Sabah when the rest of the Southeast Asian region remains relatively quiet.
The wonderful thing about science is that the mystery always recedes just beyond your grasp. So even though you grab something and you figure something out, there's always something else to explain. A lot of what we want to look at right here.
The professor has agreed to share some of his latest findings. He starts by calling up a map of Sabah.
All right, so if we draw a line like that, that basically is this line. So you can see these little guys here are a place where the land is splitting apart, and these out here along the seafloor, very deep, there's a little fault, a big fault like that. So one hypothesis, which has not yet been proven, but it's one idea, is that this block is simply sliding like a giant landslide, and these earthquakes, these faults basically allow the stretching at the top, and these faults allow the shortening at the base.
So you said this hypothesis is pointing to the fact that Sabah is slowly sinking.
The implications are that if we looked at the GPS data, there should be a stretching across Sabah, across here. And then that stretching occurs, and then boom, it's released by an earthquake, like that.
So this is shifting.
Gravity basically causing it, in this case, an entire half of a province to slide into the water.
Over the last 100 years, records show there has actually been 4 earthquakes of similar size within a 300-kilometer radius of the Sabah earthquake. Could these earthquakes be part of a bigger story? A story that is pointing to the possibility that Borneo is slowly stretching apart along the valleys I saw for myself at the epicenter in Kundasang.
We think that the very little geodetic data that's available for Sabah suggests that it's stretching at about 5 millimeters per year. So about, what is that, about 1/5 of an inch a year. And that, over the centuries, builds up enough stretching of the sponge, the rocks, that boom.
So does this ongoing stretching across Borneo suggest Sabah is due for another earthquake in the coming years?
The layman has to realize that science doesn't happen overnight, that predictions aren't made overnight. Just like a parent knows that he can't expect a 5-year-old next day to end up being a professor. So there's a 20-year process of growing up between a 5-year-old and a 25-year-old. So we're at the 5-year-old stage right now in Southeast Asia with regard to earthquakes.
My journey has revealed that unraveling the precise cause of the Sabah earthquake remains an ongoing scientific mission. A mission to ultimately benefit future generations as they begin to make sense of their world.
I'll remember my best friend because she died on the day itself.
I'll remember the good times I had with my friends, because we went out together, we had fun times. Then after that we found out they passed on, so it's quite hard for us to move on.
In my mission to decode the Sabah earthquake, there's been a fascinating journey, sometimes going beyond the science. A journey that has reminded me that life on this planet can be a fleeting moment, and that our sense of mortality should never be forgotten.